I wanted to cover for a minute my dissatisfaction with the energy crap these days and all the technology for it. So this is a furnace. This is like a Carrier or Bryant. It's made by ICP. I can't remember what ICP stands for right now, but anyway, ICP makes Carrier, they make Bryant, they make Payne. Carrier and Bryant are kind of their primary product lines, and then they filter all their technology down to Payne. And I believe that this unit is manufactured in 2008. So, it's either 2003 or 2008. I'm pretty sure it's 2008. We replaced this furnace last year, and the reason we replaced it is because this failed. This is the inducer motor. It still turns, but it sounds like there's a bad bearing or something. I don't know what the deal is. But the problem with this particular unit is this thing is like $1,000 in itself, our cost. This unit is what we would consider like a modulating furnace. So instead of just being a high fire or a low fire, it kind of ramps up and it ramps down. And to do that, these things have a computer chip. If I was to take this off, there's a computer chip in there. And you can see how many wires. There's not just a hot and a neutral, you know, for on and off. There's all these control wires, speed wires, all that. So, and for whatever reason, the bearing's going out. You can hear it kind of grind or whatever. We changed out the heat exchanger. The heat exchanger is this huge component in the back. This part right here is the heat exchanger, and it goes all the way down there. When we do these, we kind of use them as trash cans. So anyway, we changed out the heat exchanger last year on Carriers and ICPs and Bryant's. The heat exchanger is warranted for 20 years typically, and it's not great. I mean, the warranty is great, but the heat exchangers have a tendency to soot up. It's just the design. I'll see if I can put a photo in the video if I'm talented enough. But anyway, so the heat exchangers soot up, they get warrantied out. You know, the repair for us takes maybe, you know, a couple hours, 2-3 hours to do. The heat exchanger itself costs like $2,000 when you buy it, but when it's under warranty, we only charge a customer like $600-700 to replace it. So it's fairly inexpensive, and you can theoretically buy, you know, an additional 5-6 years out of this thing for that kind of money versus doing a new one. So when we did the heat exchanger last year, I heard this thing, and my suspicion is with that heat exchanger sooted up, it stressed this out because it increases the air resistance of the exhaust. So this thing's working harder, and I think that's kind of the story. So when we did the heat exchanger, it was like, hey, this guy is not doing too well. You can hear it, and you know, whatever. So we did the heat exchanger. It worked great. This thing failed kind of right around New Year's, and she opted to go with a new one because if we buy this, it's like $1,000 my cost. You know, usually we would charge a customer like $1,500 because we have a trip charge and an install and all that, and you know, maybe a little markup so that we can actually warranty the product. So she didn't want to put $1,500 into this furnace. She opted to go with a new unit. I think I charged her, I don't know, it was like $3,800 or $4,000 or something like that. So it's not too bad. So whatever. I mean, that's fine. But my issue with it is, if you were to do a normal single stage furnace, this component would cost maybe like $150. A normal single stage component where it's just got the hot and the neutral, maybe a ground, where it's on and off, it's relatively cheap. You know, call it $150. Usually we charge people the $110 trip charge plus a little markup. You end up getting out of the house for like under $500, and that's a reasonable repair for most people. So, you know, this thing here, this furnace is maybe a, you know, I don't know what the efficiency of it was back then, but if it was a new furnace today and it was a modulating furnace, a single stage furnace for us to install it is, we're charging around $4,000. For a modulating unit, kind of like this one, you'd be somewhere in like the $5,500, maybe $6,000 range. You get a couple percent more. That single stage unit I was talking about is like a 96% efficient, which is pretty good. You're losing 4% of your potential heat there. And that's pretty darn good. Whereas a modulating unit is maybe like 97.5. So you're adding up, you're adding an additional $1,000 risk to a future repair for maybe 1 to 1.5%. So it frustrates me a lot because, usually I just try selling single stage. I get some customers that are energy conscious or whatever. They want to get something else. And you're just opening yourself up to a lot of headaches. So, that's the same with the gas valve too. This gas valve is, it's like this one's a 2-stage. For a 2-stage gas valve, if we were doing a single stage, we'd be at like $450 for the repair. A 2-stage gas valve, you're somewhere $600, maybe a little bit more. So there's just additional components on here that are super expensive too. The control boards are always more money. I mean, look at the pressure switch bank. This thing has, is it just 3? Yeah, it's 3 of them. So you have 3 pressure switches there in a row. If one of them fails, that's fine. You can usually replace the one, but it's just more chaos. And, for what? So, anyway, that's my take on that. If you're in the mood for a new furnace, I would consider just going with a normal efficiency unit. In fact, these are considered high efficiency. They're 96%. That's why they have the PVC exhaust. If a customer has an 80% efficient furnace currently, I really try to talk them into an 80% efficient furnace because there's so many components on that thing, or on this compared to the 80%. On an 80%, you don't have condensate. So you don't have the condensate trap, you don't have the condensate drain. The inducer is much more simple. It's a metal design. Typically you don't have 2-stage. Sometimes you do. And you don't have the secondary heat exchanger. Let me see if I can't show it on your phone. I'll find you a secondary heat exchanger so that you can see that. Let's make sure you guys can see that. No, we can't see that. Yeah. Okay, so this is a heat exchanger. This is out of a Goodman, so it's a little bit different, but there's 2, you can't really see it from here. There are 2 heat exchangers put together here. So when the thing runs, you have flame going down these tubes. You can see this one was all charged. Then flame goes down. On this particular unit, it goes through these big tubes. These big tubes are what we call the primary heat exchanger. And then the secondary heat exchanger, this is the secondary heat exchanger here. So you can see there's little tubes. On the Carrier and ICP, the secondary heat exchanger is actually like these thin channels, which is why they plug up. I don't have one in front of me, but I am taking one out later today. So that's something. But anyways, on an 80% efficient, you just have this. You just have the primary heat exchanger, these tubes. So sometimes they do burn out. Sometimes you'll get charring here or something. I can link a photo on that. But most of the time, a secondary heat exchanger doesn't have any issues. So anyways, that's just kind of my gripe over modern technology and how everybody wants energy efficient stuff now. I think that you're just shooting yourself in the foot because the more and more complex things are, the more it's going to cost. Some of these units too, we're getting to the point where we're like the automotive techs, where eventually we're just going to have diagnostic computers where we plug stuff in and it tells us codes and stuff. Right now it'll tell us a code based on blinking. We can put an electrical meter on stuff. It's getting to the point though where electrical meters aren't enough. We're going to have to start using scopes where we can kind of map the electrical paths and all that. So anyways, that's my take on that. It doesn't really matter to me what one people take, but I would go with the lower efficiency and more reliability personally. So Thanks for watching, subscribe, and we'll talk to you soon.